How's it going? Good. I'm doing well, thanks. Are you ready to go back to co-op? You ready to see your friends, but not ready to do the work? Well, we'll wait a few minutes. Maybe people thought it was 12:35 since that's our usual class time. Hey, Jack. Hey, Olivia. Hey, how's it going? No problem. We thought maybe people thought it was because it's 12:35 usually at co-op. Okay, I think Sophia should probably be joining us soon as well. So, how's everybody doing? Good. Good. Thanks for joining me today. So what I wanted to do today is just keep kind of chugging through chapter 5. But I just wanted to start off first with any questions or if anybody feels like they needed any review of anything. And we'll kind of be doing review mixed in with the new sections anyway, because it's kind of the same idea. But I did want to give you guys the chance to kind of ask any questions. Anyone got anything? Nope. All right. Well, let's go ahead and dig in so that we can get you on your way. So last Monday, which is recorded if you didn't get a chance to watch it, we went over we really kind of reviewed section 5.4, which was FOIL and factoring. And then we went over section 5.5, which is called the difference of two squares. And the difference of two squares is kind of like a special case for factoring. So only numbers that have a perfect square kind of fall into the category of difference of two squares. So we're going to kind of continue on that today and actually move to section, where did it go? 5.6. For some reason, they're broken apart. 5.6 is another kind of special case that when it comes to factoring and foiling. So 5.6 is called the squares of binomials. So don't let all of the terminology and the words binomials and perfect square and all that kind of trip you up, because really it has to do with doing the same kind of processes. It's just different special cases. So just to kind of review for everybody, it's always good to review FOIL. When we have an equation, let's say we have, oops, let me change to black here. So we have x squared plus, and I'm trying to think in my head. Sorry, I'm trying to do the reverse off the top of my head. Well, let me do it the other way. That'll be easier. All right, so if we have this, let's do this. X plus 3x, and we have x minus 2, okay? And we have an expression that's written like this. This is called a factored equation. So if you hear somebody say factor the equation, they want it to look like this. This is factored, okay? And if we want to write it in the standard way, that means that we are going to have to use FOIL. Basically, and FOIL, what that does is it gets rid of the parentheses. It gets rid of the factoring, okay? So to FOIL, what we do is we do our first, outside, inside, last, right? So first is going to be x times x, our plus our outside, which is going to be negative 2 times x, plus our inside, which is going to be 3 times x, and our last is going to be 3 times negative 2. So when we put this all together, we're going to get x times x is x squared. Negative 2x plus positive 3x is just going to give you x. And 3 times negative 2 is going to give us negative 6. Okay, so this equation right here, this expression, and this expression up here are equal to each other. These mean the same thing. So if I put in x equals 0, up here I would get negative 6, and down here I would get negative 6. I'm going to get the same answer. They mean the same thing. They're just two things written in the same way. So all of this work we're doing is basically rewriting things in a different way. Okay. And what we're doing in all these sections, starting with 5.4, is we're learning how to go from writing it one way to writing it the other way and back. So if your directions say to factor, that basically means that they want you to take an expression and write it like this. So if your directions say factor, they want you to go from this way to this way. Okay. If your directions say to simplify means they want you to go from this form to this way. All right, so I just that's a whole bunch reviewed into one, but that's what's going on with that. So 5.4 talks about all general kind of cases. 5.5, we talked about a specific case. So let me clear this off. And 5.6, we're going to talk about another specific kind of case that's under that. So the good news is, just because they're a specific subset of the regular kind, you're going to use all the same things. You're going to use FOIL and to factor, and you're going to use the same techniques to simplify. So we don't have to learn anything new. We just have to kind of apply it to a new situation. So what do I mean by that? Well, the first thing is we have x minus 7 squared, and we want to be able to simplify that. Okay, so this looks a little bit different than our standard equations that we've been working on, but we actually can use the same equations that we worked, or the same processes we've used in the past to solve this. Okay, so what does x minus 7 squared actually mean? Well, that's the same as x minus 7 times x minus 7, right? Just like x squared is x times x, x minus 7 squared is the same as x minus 7 squared times x minus 7 squared. So do we know how to simplify this? You guys feel like you could do that? Probably, yeah. Olivia, you remember how to do that? I won't call you guys out and make you do it. Kinda. All right, so let's do some practice, all right? What's that? X squared. Uh-huh. Yep, so you're going to use FOIL again. FOIL is going to be your friend, okay? So FOIL is first, right? So our first ones are x times x. X times x. Plus our outside. So our outside ones are -7 and x, right? -7 times x. Don't forget these negatives belong to the number after it. The subtraction is like a negative, right? Our inside is -7 times x. And our last term is going to be -7 times -7. Okay, so now I've got to do some simplifying. X times x, like I think Jake, you said it's going to be x squared, right? It's going to have an exponent of 2. And my 2 is terrible. I'm trying to write it on there. There we go. X squared. Okay. Yep, -14x. And then -7 times -7 is going to give us +49. Okay, and this is where that list of perfect squares is going to come back in handy. Remember, 7 times 7 is 49. You want to know 7 squared is 49. This is where it's going to come back into handy for that. Okay, so this up here, what we originally started with, so let me highlight over. This is the same as this. Oh, that did not work. Where's my undo button? These are the same exact expression. They're just written in different ways. So if you put in x equals 1 to both of these, you're going to end up with the same answer. Okay, so I just want to make sure you understand we're not actually doing anything to any of them. We're just kind of rewriting them. Okay. So let's do another example that's like that, because that was kind of a mess. Hey, how are you, Sophia? Good. We just did some review, and we're kind of starting 5, 6 right now. Awesome. So then you kind of reviewed it on your own. Okay, so we're talking about something called we're talking about something called squares of binomials, but I was telling everybody not to get too confused with the wording. No? I don't think so. Sophia, Jake, Jack, and Aaron is Olivia. Olivia is selling clever containers today. She's very organized. Okay. So let's do another one. So if I have, let's do t minus 5 squared. And I asked you to basically evaluate or simplify is what the directions are going to say. Okay, so what you're going to want to do is, because it's squared, you can rewrite this as t minus 5 times t minus 5. Everybody okay with that, right? We can rewrite it like that. We then, to be able to simplify this, to basically get rid of the parentheses, we can use our good friend FOIL to help us get rid of the parentheses, right? It's our tool to get rid of those. So FOIL stands for first, outside, inside, last. So when we FOIL, our first is going to be t times t, which is t squared. Okay. Our outside is going to be times negative 5. So plus negative 5t. Our inside is negative 5 times t, so plus negative 5t. And our last is going to be negative 5 times negative 5. So then when we go to do some simplifying, we have t squared plus negative 10t, because negative 5t plus negative 5t is negative 10t. And then negative 5 times negative 5 is going to give us positive 25. That's a plus. Okay, so this expression down here and this expression up here mean the same thing, just written two different ways. You could also write this if you wrote it as t squared minus 10t plus 25. That's also the same thing. Okay, those are equivalent to each other as well. Okay, so then everyone starting to feel a little bit more comfortable with that? I have one more example from the notes. Okay, I have another example from the notes too. So sorry for the scrolling, 10p squared minus 6q squared. This is like a tricky one. So let me write this. Sorry, keep flipping to the wrong thing. I don't think you guys want to do geometry yet, do you? Where's my paint at? There we go. All right, so this is 10p squared minus 6q squared, the whole thing squared. So I'm going to give you guys like a 3-minute head start to try this on your own, and then I'll start writing down the steps. So I'm not going to call anybody out, but I want you to just try this to see how far you get, or if you kind of get stuck, then you can figure out, okay, that's where I'm getting stuck. That is a Q, yeah. That crazy letter is a Q. Let me fix it up for you. All right. I'll start doing it here. All right, let's see. So the first thing that you want to do is recognize this whole thing is squared, right? Everything in the red here is squared. So we can rewrite this as 10 p squared minus 6q times 10p squared minus 6q. Okay, so that's the kind of the first step, is to recognize, okay, that's the whole thing is squared, so we can rewrite it as that. So once we have it written like that, we're like, huh, this looks an awful lot like FOIL, right? Two binomials that are multiplied together. That's how we'd say it in mathy words, but it looks like a problem that we FOIL, right? So we're going to do first. So first is going to be, I'm going to write all these steps out. 10p squared times 10p squared. Okay, that's our first. Our outside is going to be plus. So we always do a plus in between our FOILs, right? It should really be like F plus O plus I plus L. So our outside is going to be 10p squared times negative 6q. Our inside is going to be negative 6q times 10p squared. I'm going to run out of space. And our last is going to be negative 6q times negative 6q. Sorry that I totally ran out of space. I'm going to switch colors just so you know that this is the next line. Okay, so now I've got to do some simplifying. 10p squared times 10p squared. So 10 times 10 is 100. And p squared times p squared, and I can't remember if we did all our rules yet, but that's actually p to the 4th power. So if you think about it, it's just p times p times p times p. So there's 4 p's. That's a terrible p. Sorry about that. Okay, now we have our second. We've got 10p squared times negative 6q. So 10 times negative 6 is negative 60. And then we've got p squared and q. We can't combine those together. They're different terms, right? So we've got p squared and q. Then our third term, we have negative 6 times 10. So we have negative 6 p squared q. Same, it's basically the same as the outside and the inside are the same, right? And then last we have negative 6 times negative 6, so positive 36. And q times q is q squared. Last thing we can do is combine these middle two guys together, right? Because they both are p squared q. So we could rewrite, instead of you guys waiting for this, we could rewrite as negative 120 p squared q. Let me scroll down a little. 100p to the 4th plus 36q squared. So that was a really hard one. I mean, that was a complicated one, right? We had squared terms inside of other terms. So that made it a little more complicated. Cool. Nice. How about everybody else? Get part of the way there? Yeah? Part of the way? Yeah. Yep. You guys will have to get used to it for next Monday, right? All right. So that is one thing, okay? Do you want to see another example of that, or you guys feel okay with that? I hear some cuteness at your house. Hi. All right. So you guys okay? Need another example? Feel like you doable? Yeah, it's not too bad. So now what we're going to do is kind of work back the other way. Okay? So what do I mean by that? If you go to your notes, it's going to ask you if this is a perfect square. So these examples that we were doing, how they kind of rolled up together into one, these are called perfect squares. Okay, that's why I said that's like a special case, but you do it the same way as everything else, right? So x minus 7 squared is the same as x minus 7 times x minus 7, right? We talked about that. But this is kind of a special mathematical case that we call a perfect square. Okay, so what they're basically asking you when they say, is this a perfect square, is can we factor this so that it turns into something that looks like this? All right, so from now on out, you're not just going to be just evaluating using FOIL. You're basically going to be sometimes, I would call it, I unofficially call it unfoiling. So you're kind of working your way backwards from foiling. Okay, so let me show you what I mean by that. So we have x squared minus 6x plus 9. Let me go over to paint. Oops. X squared minus 6x, right? Plus 9. Okay, so what we're trying to do is we're trying to get it to this format. Okay, and what we want to do is we kind of want to think of this as unfoiling. Okay, and so what I mean by that is you can kind of use your ideas of, oops, I'm getting feedback. Hello? Okay, there we go. Hello? Okay. Oh, no, I was like hearing myself talk, so I was getting feedback. Usually that happens when there's like a mic unplugged or something. So what we kind of want to do is we kind of want to be able to unfoil. Like I said, this is my unofficial math term, so it's okay if you've never heard it before or don't hear it again. But people seem to understand why I say unfoil. So we're going to kind of unwrap this and see if we can figure it out. So what I mean by that is we know that the first term is x squared. And the way to make x squared, we're trying to figure this out, is we could say, oh, to make x squared, I need to have an x times an x, right? So that's my first term in foiling, but we wanted to kind of do the opposite. So I want to do x times x in order to get x squared. The next thing you want to look at is the last term, because the inside outside kind of are a little confusing, but let's look at the last term. Okay, so we have 9. So I have to think, what are all the ways my last two terms, I multiply them together, right? What are all the ways I can make 9? I can make 9 1 times 9. I can make 9 3 times 3. I can make 9 negative 1 times 9. No, negative 1 times negative 9. Or negative 3 times negative 3. So which of those 4 choices do I pick? Well, one option is that you could try each of the 4 and then foil it and see what works. Another option is to try to kind of be a little bit smart and think, not that you wouldn't be smart if you tried the other way, but try to be a little bit smart about it and think, okay, and my inside and my outside, I need to get to 6. So do I think that 1 and 9, like either adding or subtracting together will get me to 6, or 3 and 3? So 3 and 3 is definitely seems like a better possibility to get me to 6 in the middle. Okay, So I think I'm going to need a 3 and a 3 here. They could either be positive 3 times positive 3 or negative 3 times negative 3. So I know that I actually not only need to get 6, but I need to get negative 6, right? So in order to get a negative 6, I probably need to use negative 3 times negative 3. So there's not an official unfoiling method. It's kind of a technique of learning how to do it. Okay. Are you guys following so far? Did I lose anybody completely? Doing all right? Anybody else? All right. All right. So what we did is we kind of made a guess for this x squared minus 6x plus 9. And we said we think it's x minus 3 times x minus 3. How do we actually check to see if that is the true factoring of this? How do we check to see if they're actually equal? Well, what we can do is then we can do regular FOIL again. You can be foiling like crazy, right? So x times x is x squared. Our outside is x times negative 3, so negative 3x. Our inside is negative 3x. And our last is negative 3 times negative 3, which is 9. And so this is x squared minus 6x plus 9. Yeah. So one way we go, like, you know what I mean? We're kind of like undoing. We're we're factoring and then we're foiling to get back to the factored version. So these mean the same thing. We're just kind of rewriting them in different ways. Now, if you'll remember, we're talking special cases here. So they want to know if this is a perfect square. Well, look at this. We've got x minus 3 times x minus 3. We could also write that as x minus 3 squared. So we would say, yes, this is a perfect square. Okay. Okay, so let me do another one. Okay, so the next one is going to be, close that. 9t squared minus 3t plus 1. 9t squared minus 3t plus 1. All right, so we want to know if this is a perfect square. Let me make sure I wrote it right. Yep, I got it. Oh, plus 1. All right. Yes. Okay, so how do we figure out if it's a perfect square? What we're trying to do is we're trying to figure out, can we put it into these two parentheses? Okay. So this one, I'm actually going to start with unfoiling it, right? And instead of starting with the first term, I'm going to start with the last term. Does anybody know what that is? The last term in here is the last, right? The last term is a 1. So what's the only way to make 1 when you're multiplying? 1 times 1, right? So we have to have a 1 here, and we have to have a 1 here. So that's good. All right, so now I want to go to my first term, right? My first term is a 9t squared. So I know it's going to have to be, to get t squared, is going to have to be t times t. And my different ways of making 9, just like the last example, were 3 times 3 or 1 times 9. I think I'm going to go with 3 times 3, right? Now the last thing is, what signs do I put in here? Well, I know my middle term is negative and my last term is positive. So in order to get a middle that's negative and a last term that's positive, I'm going to need to do negative times negative. But I don't even know if this works. How do I check if it works? Well, I used unfoil to try to kind of create this. I'm going to use foil to see if it works. So let's try foiling it. So 3t times 3t is 9t squared, right? Then my outside is 3t times negative 1 is negative 3t. Negative 1 times 3t is negative 3t. And negative 1 times negative 1 is positive 1. So when I do this, I actually end up with 9t squared minus 6t plus 1. So was I successful? Is this the right version of that? Nope. Nope, because look at up here, it was negative 3t, and down here it's negative 6t. All the other two sides are okay. So sometimes they're going to work out and sometimes they aren't. This one is no. Oh, you want to know which one is? Sometimes they can't even be factored. I would guess this one actually couldn't be factored. Sometimes you can't make it right like this. So this is wrong. This is a factor of something. It's just not a factor of that, right? And actually what we're going to start doing, so you kind of get a sneak peek in these two sections, but what we're going to do in the next section, which I think we're going to go ahead and do, because it's actually easier in these, is we're going to talk about factoring. So there's a whole bunch of words up here about factoring. You can read through them if you want, but we're basically going to just keep doing the same thing. Factoring, or you can think of it in your mind as unfoiling, because that's how I think of it. Yeah, I think we're just going to do those two today. Oh, like which problems to do? Yeah, so in 5-6, I want you to do 1 through 31 odd. And then 5-7, I want you to do 1 through 29 odd. It'll be done when when we're done with chapter 4. So it'll be after next week. Yeah. You don't have to turn it in Monday. Huh? You don't have to turn anything in on Monday. Yeah. But you don't have to turn them in. I mean, I would encourage you to get them done though. So you're not starting off behind, right? Yes. Yeah, you'll have a test on the rest of chapter 5. Yeah, because it's over the new stuff. Sorry. All right, so here's the deal. You know that stuff we were just talking about, factoring or unfoiling? I'm sorry for all the scrolling. 5-7 is factoring. Section 5-8 is factoring. Section 5-9 is factoring. And then we skip and we do section 5-12. So basically the next 3 sections are all the same things. They just kind of like make it a little harder each time. Does that make sense? You know how like you start off and you learn to multiply 2 times 5, and then you learn to multiply like -2 times 5, and then you learn how to multiply, 200 times -5 or whatever. Like you kind of build. So Basically 5, 7, 5, 8, and 5, 9, same exact thing. We're just going to add little elements in to make them a little bit harder. So that's why if you get your 5, 7 homework done this week, when we come to class and learn 5, 8, and 5, 9 next week, you're going to be that much ahead because you're like, oh, I practiced this a lot. I'm okay. I just add this little twist in and I got it. Does that make sense? Okay. So let's go ahead and dig into this so that I'm not keeping you here too crazy long. So all we're going to be doing is factoring, and factoring means that they want you to not write it as an expression. They want you to write it like this. Okay. There are several techniques out there about how to do this, but it's a little bit of a, I want to say a math kind of art to be able to do this. You kind of just have to, there is steps that you kind of want to take, but you also kind of have to look at the big picture. Kind of like a puzzle, like a math puzzle, I guess. All right, so we have y squared plus 7y plus 12. Okay, we know that the first term is y squared. That's awesome because that means it has to be y times y, right? Easy peasy. Everybody good with that, right? Because when you go ahead and FOIL it later to check it, your first term is going to come out to be y squared. So is everybody okay with that? How I get this y times y here? Yep. Cool. All right. Then we go to our last term. So we have a 12, right? We think of all the ways that we can multiply to get 12. And this is why back in chapter, I think it's the beginning of chapter 5, we kind of talked about, remember how we talked about all the factors of a number? I think it was even on your quiz, like, you know, give me all the factors of 64. That's why we did this work, because I need to know all the ways to make 12. So 12 could be, and it's a positive 12, 1 times 12, 2 times 6, or 3 times 4. Or it can be negative 1 times negative 12, negative 2 times negative 6, and negative 3 times negative 4. Okay, so all of these make positive 12. So any of these combinations could go in my last. And this is where kind of the puzzle part comes in. Before you just, well, I shouldn't say that. You could sit there and plug each of these in. You could do it 6 different times and then do FOIL and check and see which one works. That is one method. Just a very time-consuming method, right? Or you can look and say, oh, in the middle, I'm trying to get positive 7y, and I'm really just looking at the positive 7. When I look over here at all these combinations, which one of these, because remember we always add our outside and inside together, which one of those combinations gives me positive 7? So 1 plus 12 gives me 13. 2 plus 6 gives me 8. 3 plus 4 gives me 7. So I am thinking I want to use 3 and 4 to get my 12. Okay, so I think I want to use 3 and 4. And I want to use the positive version because I have a positive 12 and a positive 7. So I want everything to just be positive. Okay, so what you're literally going to do when you factor is you're going to make a good guess. Not a complete, out of the blue guess. You're going to make an educated guess, right? I think this is how I'm going to factor y squared plus 7y plus 12 based off of the first term and the last term and what I know. I don't actually know if this is the factored version until I do FOIL to check it. So I'm going to FOIL what I just did. So I already know first is y times y. Outside is y times 4. 4y. Inside is 3 times y. And last is 3 times 4, which is 12. So now if I do that, y squared plus 4, or 4 plus 3y is 7y plus 12. So now that I factored and then FOILed again, I know, okay, this matches this, so this is the right factor of y squared plus 7y plus 12. Okay? Do you guys follow along with that? Cool. Let's do another one. You're like, no, don't make me do more. All right. I'll go a little bit faster, but still try to explain everything. Okay. X squared minus 12x plus 20. Okay. Factor. Factor means get my parentheses, right? Okay. X squared, easy. I can do x times x to get that. 20. What are all the ways I can make 20? Well, I know it's 1 times 20, but that's not going to get me to 12. I know it's 2 times 10. Oh, 2 times 10 is interesting, right? 2 times 10, and 2 times 10 gives me 20, and 2 plus 10 gives me 12. All right, so I have a pretty good guess that it's going to be 2 and 10. All right. Now, what do I do about my signs? My last term is 20. So I could either do positive 2 times positive 10, which is positive 20, or I could do negative 2 times negative 10, which also gives me positive 20. My middle term is negative 12x. So negative 2 plus negative 10 will give me negative 12. So I think for this one, I'm going to have to do negative and negative. So I went through that one a lot quicker, but now this is my guess. And to check my guess, I need to FOIL. All right. So x times x, x squared. Outside is x times negative 10. You got it? Negative 10x. Inside is negative 2 times x, negative 2x. And last is negative 2 times negative 10, which is positive 20. All right, so I end up with negative 10x plus negative 2x, which is negative 12x in the middle. And I'm being a little bit lazy here with my writing, so sorry about that. So this becomes negative 12, and that doesn't even look like 12. So that's kind of the idea what you're going to be doing. Okay, let's do oh, go ahead. Yeah. You don't have to check every single one. What I recommend people doing, honestly, is checking your, really, when you FOIL, what you really need to do is the oi part of your FOIL, right? Because you've set it up so the F and the L will be right. But you don't know if the O and the I work out. So I don't need you to necessarily show me like x squared and 20 at the ends, but I would recommend, it doesn't even have to be like a perfect, written out FOIL and blah, blah, blah. But I would recommend at least, like for this one, you could just write, oh, okay, I'm going to do the outside is negative 10x plus negative 2x, which is negative 12x. Like that could be enough for that. You don't have to write, FOIL and all the steps out. Like this would be enough. Sure. Any other questions? All right, let me do 2 more just so you're not stuck. So you don't get stuck when you're doing your homework and you're like, Mrs. Ross didn't show me this one. M squared minus 18m plus 30. Okay, so they want me to factor it, right? M squared would be m times m. 30. There's a lot of ways to make 30, right? 1 and 30. 2 and 15. 3 and 10. I don't think 4. 5 and 6. Right? All of those are sloppy ways to make 30 because I'm writing crazy. All right, so now I need to go and figure out what combinations of these is going to give me 18m. 5 and 6, you think? Well, 5 plus 6 is only 11, so that's not going to quite get me there. Yeah, 3 plus 10 is 13. 2 plus 15 is 17, and 1 plus 30 is 31. Huh? What's going on here? Well, one thing, you might try a few of these out, right? You might kind of try them out. But since we're kind of short on time, I'm going to abbreviate this for you. Sometimes they will give you a problem like this, and it's actually not factorable. There's not going to be that many of them that are not factorable. Not factorable. Yep. Yeah. I mean, you maybe show some thinking work if you've thought of all those, you can just write those down. But yes, you just say, oh, nope, this one is not factorable. I will warn you though, if I give you a test, I'm not going to give you 5 out of the 6 of them are not going to be factorable. Most of them are going to be factorable. Sometimes I tell people that and then they're like, every other one is not factorable. Okay. All right. What about this crazy number 4 here? 24 minus 25u plus u squared. What's up with this guy? So there are 2 options that you have with this. One is, do you remember, just because it's written this way, it doesn't mean we can't rewrite it. So we could just rewrite this as u squared minus 25u plus 24. And that's the way I would recommend. The other way is you can factor it the way it is, but I would just recommend rewriting it in the form that you're comfortable with. Right? And this is a u, not an a or whatever. Okay, so now we can factor it, right? What's u squared going to be when we factor it? U times u, right? U times u. And then our last term is 24. And our middle term is 25. So does that set off any bells in anybody's head? What do you think we might want to use for if we need to make it to 24 and then we need to add up to 25? What about 1 times 24? Right? What about 1 times 24? Because 1 times 24 is 24. 1 plus 24 is 25. Last up is, which signs do we put in? I have a positive 24 and I have a negative 25. So is it going to be positive and positive or negative and negative? Well, since we have a negative right here, right? The only way to get that is if we have a negative and a negative. So if you were writing down your notes, if you'll notice, when you have a positive and a positive, you're going to end up with a positive and a positive on the inside. When you have a negative and a positive, or a negative and a positive like you have here, you're going to end up with a negative and a negative. What's up? That's actually what we're going to talk about in the next section. In 5-8, one's going to be positive and one's going to be negative. Yeah, that's coming up next, Sophia. Next week. Unless you want to do it now, you know. Yeah, you got it. Awesome. So that is that. So we actually got through almost everything. I can do, actually, let me do number 5 for you. No, we're done. I think we're done. I can do number 5 if you really want me to. If your brain's done, you've got enough information in there, you think you're ready to try it, you can go ahead. I don't even know if you have an yeah, it shouldn't be too bad. Awesome. All right. Well, thank you guys so much for coming. I can stay on for a little bit longer if anybody has any questions. If not, you're free to go. And I will see you in person next Monday back at co-op. Come on, it'll at least be fun to see all your friends. You got that to look forward to. Yeah, then just be doing it on your own. He said it's more fun to do co-op or school at co-op than just to be at home doing it on your own. Oh, yeah. Yeah. Oh, man. Well, you don't have to technically turn anything to get in on Monday, but it shouldn't be too bad to do. All right, awesome. Well, it's good talking to you guys, and I will see you on Monday. No, Yep. But if you guys need anything in the meantime, just give me, send me an email, whatever. All right. Bye. Have a good one. See ya. See you Monday. Bye.